Okay, so let's see that how we will solve the heat equation using Crank-Nicolson method. So this is the problem that ut equals to uxx, where this is the boundary condition, and this is initial condition. So we have to solve this ut equals to uxx using Crank-Nicolson method by the step size pi by 10 and 0.005 in the time direction. So we have to compute at t at 0.5, but let's evaluate only at the first level. So here is the scheme diagram that we are going to use. So this is your 0, this is pi by 10, this is 2 pi, this is pi by 10, this is 2 pi by 10, this is 3 pi by 10, this is 4 pi by 10, 5 pi by 10, 6 pi by 10, 7 pi by 10, 8 pi by 10, 9 pi by 10, and pi. And this is your 0.005, this is 0.01, this is 0.15. So this is your pi by 10, this is your 9 pi by 10, and this is 0.005. So 0.005. Okay, so in the same way it will go up there. Now see, now the initial condition is given as the sin x and the boundary condition is given 0. So what it means that on this way, here that u is equals to 0, and again here also u is equals to 0 given. So in this way u is equals to 0 is given, and the initial condition is given sin x. So let's compute we'll use the initial condition for computing at 0th level. So we'll compute, so what's the value? Let me calculate it. Sin x, start from 0 and to pi. Yes, so this value is of course 0, so this is 0. At this point it is 0.30902, at this point it is 0.58779. At this point 0.80902, at this point 0.95106, at this point it is 1, and again 0.95016, 106, and again it will repeat here. Okay. So this is the scenario. Now so let me write first the FDMX scheme for this Crank-Nicolson method. So it's so R is given as c square k by h square. So this point is your, let's say, minus r. This is your 2 plus 2r, and this is your minus r. This is your r. This is 2 minus 2r. And this is r. Okay. So what it is that minus r ui n plus 1 plus 2 plus 2r I minus, this is I minus 1, this is I n plus 1 minus r u I plus 1 into n plus 1. This is equals to r u I minus 1 at nth level plus 2 minus 2r into u I nth level plus r u I plus 1 at nth level. Okay, so this is the scheme, the formula that we are going to use. So see, we know the value at this point from the last diagram. If you see the last diagram, we know value at this point. See the last point, the values at this point we know, the values at this point we know, the values at this point we know, and we are supposed to find the values at this point, this point, this point, this point, and this point. After that, this all will repeat. After that, this all will repeat. This all will repeat. So only we will have to find the half of the value, and after that all will repeat. Yes. So this is the scheme. So if you write it in the matrix form, so how it will looks like, it will be 2 plus 2r minus r 0 0 minus r 2 plus 2r minus r, then 0. Similarly it will come, and it will come minus r and 2 plus 2r. This, let me write u1, u2, u9, and if you write the right hand side matrix, so it will be, since the boundary conditions are given 0, so we'll just consider this only. So r, sorry, 2 minus 2r, r 0, and r 2 minus 2r, r 0, and in the same way here will come 0, and r and 2 plus 2 minus 2r. So this is also 9 by 9 matrix, this is also 9 by 9, so 9 cross 9 matrix, and this is also 9 cross 9 matrix. But we can reduce this matrix to 5 cross 5. Why? Because see from the last diagram, this is your u1, u2, u3, u4, u5. Now this is nothing but u4, this is u3, this is u2, this is u1. So instead of writing 9 by 9 matrix, we can reduce this matrix to 5 by 5 matrix. So let's see how we'll do that. So this is your u1 into this, u2 into this, so this will remain same, this will remain same, this will remain same, so till 5th level will here. So let's see that how the matrix will look like. So the let's first write the equation, all the equation, then we'll see that how it will look like. So it will be 2 plus 2r into u1 minus r into u2 plus 0 into u3 plus 0 into u4 plus 0 into u5 is equals to something that will compute later on. Now this minus r into u1 plus 2 plus 2r u2 minus r into u3 again plus 0 u4 plus 0 u5 that will compute later, and similarly minus 0 u1 minus r u2 plus 2 plus 2r u3 minus r u4 and again plus minus plus 0 u5 is equals to again something 0 u1 plus 0 u2 minus r u3 plus 2 plus 2r u4 minus r u5